Hello there, this is Dr. Henry, and today what we're going to be looking at is how do you predict the products of different types of reactions. And so in order to do this, what you really need to know is how to identify reactions, because that's going to help a lot. And if you can identify reactions as single replacement, double replacement, combustion, synthesis, decomposition, then this will be much easier to do. So let's look at an example. So we have barium chloride plus sodium hydroxide, and we want to predict what the products are going to be. Well, just looking at this, with two compounds, what is this reaction probably going to be? It's not going to be combustion, it's not decomposition, it's not single replacement. So really, all it could be is synthesis or double replacement. And for as far as our class goes, if you have a compound plus a compound, it's going to be a double replacement reaction. So this is going to be double replacement. So what happens in double replacement is the metals replace each other, or the positive ion. Sometimes it could be a polyatomic ion in front. Sometimes it's possible you could have hydrogen as a positive ion. So really, the positive ions or metals switch places with each other. So what we'll get on this side then is we'll get barium with hydroxide, and then we'll get sodium with chloride. And then what you're going to have to do is you're going to have to look up the charges of these. So barium is in group 2, so it's +2. Hydroxide is -1. Sodium is +1. Chloride's -1. So let's write the formula. So we get barium hydroxide plus sodium chloride. And then we want to balance it. So let's look. We got one barium, one barium. We have one sodium, but look, we have two hydroxides on the product side, so we need 2 on this side, so we put a 2 in front. Then we need to balance sodium, so we put a 2 here. So 2 sodiums, 2 chlorines, it's balanced. So really, for what we're learning in our honors chemistry class, if you have a compound plus a compound, we'll assume that it's going to be a double replacement reaction. Let's look at another one. All right, here we have zinc, and this is an element, plus copper sulfate, which is a compound. All right, so it's not decomposition, it's not combustion, it's not double replacement because we don't have a compound plus a compound. So for what we're learning, if you have an element plus a compound, we're going to predict this to be single replacement. So we have zinc, which is a metal. So zinc's going to replace the metal in copper sulfate, and then copper is going to come out of that compound to form an element. So we'll get copper by itself plus, and then we have zinc with sulfate. So zinc has the charge of +2, sulfate's -2. So here's the formula for zinc sulfate. And then we look, this is already balanced. So with the single replacement, if the element is a metal, it's going to replace the positive ion or metal in the compound. If it's a non-metal, it's going to replace the negative ion or non-metal in the compound. All right, so let's look at this. So we have something with carbon and hydrogen. So this is a hydrocarbon. And then we have oxygen. So if you get a hydrocarbon plus oxygen, this is going to be a combustion reaction. And basically what you have to know is for a combustion reaction, the products are always carbon dioxide and water. So you just know that, you write it down. And then we need to balance this, so we need 4 carbons. We got 4 carbons here, 4 carbons here. We need 10 hydrogens. So we put a 5 here. Now we have 4 times 2, 8 oxygens. Wait, 4 times 2, 8 oxygens plus 5. So we got 13 oxygens on this side. So we need a 6.5 here. And then we got to double that. So we get 2, 13, 8, and 10. There's the balanced reaction. And then this is just, we have an element plus an element. And so we're going to call this a synthesis reaction. Hydrogen plus oxygen, right? Hydrogens plus oxygen's -2, right? So we get H2O. All right. And for the most part, the ones that I'm going to ask you to be able to write are going to be combustion, single replacement, and double replacement. Decomposition is a little beyond what we want to worry about. And really the same thing with synthesis reactions is also true. So work on this. If you need help, I'd be happy to help you before, after school, or during lunch. Thank you.